Okay, sorry. Okay, see now the dew point temperature will be how much moisture, okay, it can hold, withstand in particular volume. Say for example, when you talk about this particular year, okay, you have a dry bulb temperature, okay, and the wet bulb temperature means the more moisture in the particular year. Whenever you measure the temperature, when the dry bulb temperature and wet bulb temperature is very closer, that means it is very close to the dew point temperature. When it is equal, that means it is 100% dew point temperature. It cannot hold more than 100 percentage water, okay. So that means it starts condensing, so that is called dew point temperature, okay. So when you talk about specific humidity, it is the weight of water vapor in grains or pounds of moisture air per pound of dry air, okay. Say for example, whenever you go and measure outside temperature, it is a mixing of dry air and wet air, okay. So we how to identify dry air, wet air? You are going to calculate the relative humidity. From that there is a formula to calculate specific humidity, okay. So in that you can able to identify how much of moisture air per dry air. So that is why if you go to psychrometric chart, you can able to identify, you can able to identify 0.073 kg of water, of moistured, okay, water in the air per kilogram of dry air, okay. So that is the way this is the unit defined, okay. So this also we will do in the calculation, in the upcoming calculation. So if you see the psychrometric chart, you can able to see if this condition is the cold condition, moderate condition, this is a warm dry air, this is a warm humid, this is a hot humid, this is a hot dry air, okay. So this is the condition of the air. If you go beyond that, it is like you cannot able to either you feel like very hot or you feel like freezing, okay. So this is the condition of the air based on ASHRAE as well, okay. Then enthalpy is the energy, how much energy you are going to it will be consumed, like the thermal property indicating the quantity of heat in the air, how much energy, right. So this is the enthalpy. Then sensible heat ratio is nothing but ratio of sensible to the total heat, okay. Then the principle of heat transfer, you can also able to read this one. You can see the three types, okay, when you talk about convection, conduction and radiation, right. So this example also we will see with the picture, maybe I can show you in the picture here. Conduction means through the material, okay, like any of the material, when it pass through the temperature from one space to another space, it is called conduction, okay. Say for example, we have a wall, right, or the outside you have a outside temperature and we have an inside space, okay. When the heat will be transferred from outside to inside through the wall material, it is called conduction, okay. Through the convection means it is a different liquid, like from, say for example, when you talk about, burner, okay, you are going to heat, okay, and the heat will be converted within the liquid, okay, like the heat will be from inside, within the heat from hot to cold, okay, and there is a change in state also, so that is called convection, okay. And when you talk about radiation, say for example, if somebody is heating, okay, there will be heat will be transferred to the nearest person, or the radiation heat will be passed, okay. So that is called radiation heat. This also I can show you some of the example picture in upcoming slide, okay. And when you talk about sensible load and latent load, okay, so when you talk about sensible load, it is called pure dry load, okay. So you can say that like through the exterior walls or glazing or skylight or roof or floor or partition, okay. And in the ventilation air, you have a sensible air and dry air, okay. People in the building, people also having a sensible load and latent load, okay. If you have equipments or appliances in the summer, like any of the equipment, right, like computers or any equipment will have a sensible load. Lights also having a sensible load, okay. When you talk about latent load, it is a moisture air, okay, like people breathing. When you breathe, there is a moisture air, okay. When you cooking equipment, appliances, okay, ventilation air and infiltrations, right, okay. So this is the sensible load and latent load. And when you go to the psychrometric chart, you can able to understand dry bulb temperature, wet bulb temperature, relative humidity, then specific humidity, then you have a whatever the values, enthalpy, everything you can able to correlate in the psychrometric chart, okay. So this is the basic understanding before you go into the any of the calculations, okay. I think I will close it here. So now I will be sharing like class 0, 1, 2, 3. I'll be sharing everyone. You can go to the structure, okay. You can go to the design guide video, everything, okay. Whatever the documents you can able to go through, okay. There are each and every document is very important. I have customized, like I took it from outside only, but it is related to our calculations, okay. uh, you can able to see each and every codes and standards, right, and ASHRAE guidelines, calculation sheets, Okay, there is a software available here, HAP software. You can install the HAP software so that in the next class we will try to do the HAP calculations. Okay, through the software. But before we do the HAP calculation, I have attached one procedure. Okay, yeah. If you go to this particular guideline, okay,